Hey, hello, and welcome to the show. It is me, JP, and it's time for JP's product pick of the week. And we have a really cool one today, one that I find very useful, and I think you may too. Before I dive in too deep, I will say thank you to all the people for joining in on the chat. And if you're wondering where the chat is, maybe you're over on Twitch or somewhere like that, and the chat seems empty, head on over to our Discord. That's at adafruit.it/Discord. You'll get an instant invite to that, and you can find the live broadcast chat channel is where the chat's happening for this particular thing, for this live stream. But there's plenty of other channels for, it's much clearer, plenty of other channels for all kinds of other pursuits and questions and fields of interest. So, let's see, before I go any further, I will direct you to this URL right here and this QR code, that one, which will take you to the product page for this week's product pick. You can watch this show from inside of the product, and you will find that we have a tremendous discount. I believe it's 50% off this week. Let me reload my page. Oh, yes, it is. I'm reloading my page right now. We have them in stock, at least 100 of them, I think, and maximum of 10 per customer. So if you really like these, go ahead and grab them. You don't need a coupon code. Like I said, the price is set just during this show. So buy it during the show. If you're seeing this later on YouTube, it is too late, and I am sorry. But if you're watching this live, the discount happens right now, right through to the end of the show, maybe a little bit of a grace period after that. So the next thing I'd like to do is actually have Limor give us a little overview of this week's product pick from her new video. So take it away, Lady Ada.
This is the PCA9548 STEMMA QT breakout. Yay! So we've had a TCA9548 breakout for a very long time, but when Liz was working on the 8-channel laser harp, she connected up 8 distance sensors. She was like, man, I really wish there was a STEMMA QT version of this multiplexer that I could just plug everything in. So what this board does, as you can see here, it's got 4 VCNL 4040s. If you are trying to connect I2C sensors, you know that every I2C sensor needs to have a unique address. And so sometimes there's an address jumper or two, and like you can change the addresses, and you still have to make sure none of them collide. But sometimes there's sensors that don't have a configurable address, like I think the VCNL 4040 doesn't. And let's say you want to have multiple distance sensors because you're making a laser harp. What do? Well, this is a special chip. It's very inexpensive, and you have one port, and that's the one on the very left. That's the input port. And then when you send a special I2C command to address 70, it tells that chip to route the next I2C commands over to that port. So there's 8 ports, and so you can select which port you want to route to, and that basically lets you, without any special wiring, without any jumper pins or whatever, connect to 8 different devices with a very little amount of code that just has to go in between when you want to select between the different ones. It works very well. We've got Arduino and CircuitPython code examples and Python examples. So let me show it on the overhead, because there's a couple other interesting things. So this is your controller. So your controller connects to here, and this is also the breakout for the controller side. And then there's 8 ports. You just have to keep track, like this is port 0 and this is port 5, because when you tell the 9548 chip which port you want, you have to tell it like port 0, 1, 2, 3, 4, 5, 6, 7. If you're using a 5-volt Arduino with STEMMA QT, you might want to level shift the output. Like all of our boards have level shifters on them, but if you're using Quick or you made a DIY design, you might want to have 3-volt powered logic. So on board there is a 3-volt regulator with 500 milliamps output, level shifter, and then down here is a little switch that lets you select the logic output for these 8 ports. So even if this port's 5 volts, you can select these to be 3 volts just by flicking the switch back and forth. And this is 3 volts already, so you're not going to see any difference. But I thought that was like, we had a little bit of space left over, so I thought, why not add a little level shifter? Another thing to note is this is the PCA9548, and a lot of times these are called TCA9548, and they're actually the same chip as long as you're using 3 volt or 5 volt power. The TCA can go down to 1.8 volts, but it's also very hard to get right now. The PCA9548 is otherwise equivalent. It uses the exact same code, it's the exact same pinout. It just only goes down to like 2.3 volts minimum. So for this functionality, it's the same, just in case you're like, what's the difference between the PCA and the TCA? In this case, there is no difference. They are drop-in compatible. So this should make it really easy to make projects that use a lot of different boards, a lot of different clones of the same board with the same address with one STEMMA QT port and no soldering.
Hey, yes, there it is. So let me jump to a nice image of mine right there. Check out this little backside, nice silk screen on here. Ooh, there it is. That's my product pick of the week this week. It is the PCA9548 multiplexer for I2C. This is an 8-channel multiplexer, which allows you to plug in up to 8 boards, often sensors, but could be pretty much any STEMMA QT I2C quick type of board on these little JST connectors. And you can use multiples of the same board that have a conflicting address on I2C. So a lot of the sensors that we get have multiple addresses possible just based on what the chip allows, and then we'll break that out and give you some jumpers to go ahead and cut or solder across to choose the I2C address. In some cases, you will find we have some really cool sensors that don't allow that. They only have one I2C address, so you're kind of stuck. Well, this solves that problem. So the example that Lady Ada made was Liz's laser harp, where she had multiples of the same distance sensor that only allow you to use one I2C address. This solves that really handily. I'll show you another example that I have right here. I'm going to do some camera adjustment first. So let's get even further out like that. Now let me go ahead and focus for you. Whoop, that's pretty good. Wait, better, stop. Okay, so here what you can see is I have a QT Py plugged into the PCA9548 multiplexer, and then I have 2 of these VEML 7700 light sensors. So these have these side light sensors, which are really cool for embedding in things. But this is another one of these cases where there is no jumper for addresses. We just have one address to work with. So I've got 2 of them plugged in here, and you can see I've got the 2 light sensors right there. What I'll do is I'll go ahead and face those in different directions. Actually, let's face them in the same direction for a second. Let me put them back to back like that. Okay, so those are both pointing up right now. Now what I'm going to do is show you on a little graph here. Get this one out of the way. There we go. So this is a little graph that's showing the light sensor reads from the 2 sensors, and you can see they're basically the same. There's a small difference in them right now, but when I start really changing the lighting, you can see that's just a minor difference. So they're basically in lockstep with each other. I can go ahead and point a little flashlight at them from my phone there, and you'll see we now have 2 of these sensors. One reason you might do this is if you have multiple regions, let's say it's for a robot or some sort of escape room trick or something like that, you need to sense light in a couple of directions. Well, now you can see I've got one facing down and one facing up here. So now you'll see a big difference between these. And let's say my light comes around to the other side, and now it's pointing up at that bottom one. So now we can detect light in 2 directions with this really great light sensor that normally we can't use on a single I2C bus. This solves that. So let's take a look at the page for this. Here you go. You can see we've got this half off, so it's reasonable anyway. Normally $6.95 US. Now it's $3.48 during the show here. And like I said, you don't need a coupon code. Just throw those in your cart and buy them pretty much before the show ends is the safest thing. And you'll get these at the discounted price. Of course, you will find that there are only certain sensors that you need to worry about this with. Others you can go ahead and just use a simple daisy chain type of thing. So only get this if you need it. Only get it if you have conflicting I2C addresses, and this will solve that. And if you want an idea of how to use it, you can check out a couple Learn guides that we have here. So here is the main Learn guide on the PCA9548. This gives you all the info you need about pinouts, power consumption. One of the features of this is that you can switch the logic level. So if you have non-STEMMA QT, right? STEMMA QT, part of that standard is that they allow level shifting. They have level shifting right on the board. If you have a case where you need to switch the logic level voltage, you can do it right on the chip here with this little switch. And you can see I've got it plugged in this case right here, using STEMMA QT right into my QT Pi, but you may have cases where you want to solder in some headers or wires on the end there, and those break out the I2C pins as well as voltage there. This will give you in the guide here the pinouts and tell you how to switch the logic switch there, and then give you some examples in both CircuitPython and in Arduino for using this. Now, you can also check out Liz's guide. Let me open a different page here on the laser harp. This was done with a very slightly different version, which was that TCA rather than PCA version. It would be interchangeable in this case because it's the TCA, really the main difference is that it can go to an even lower voltage level. But this would have been really convenient. This was actually something Liz asked for because the convenience of plugging in with I2C STEMMA QT cables versus soldering and wiring would have been great. So you can check out this MIDI laser harp guide. And if you want to, you can also take a look here a little closer at the code that I have running in the case of these two sensors. So let me show you the way you use this. We're going to bring in a couple libraries. We'll bring in the VEML 7700 library for my light sensors. And then even though this is the PCA9548, we're actually bringing in the TCA9548 library. We don't have a separate one. We don't need it. It works with both. So we're bringing that library in. We are establishing I2C on our QT Pi the same way we always do. And that is what the PCA9548 is plugging into. So we create an instance of this PCA object on I2C bus. Then I have a little comment here. Normally, if we were going to use one of these VEMLs, the little light sensors, we would say variable name, in this case I just called it VEML, equals Adafruit VEML 7700 in the I2C port. But here's the main difference. When you're using this multiplexer, you will instead create that instance of the very same sensor object instead on the PCA object. So I created this PCA object up here. I'm creating my VEML on, instead of I2C, the PCA. So that's what's handling. We're feeding into that, and then that's multiplexing multiple 8 of those channels. You can see here I happened to put it on channels 3 and 4, or 3 and 4, I don't know which one's which. These start 1, 2, 3, 4, or 0, 1, 2, 3, 4, 5, 6, 7. You can put it in any of those. You don't have to start at the beginning. I didn't in this case. You just have to note which one. It's written on the silk screen, and add your sensor to that port right there. Then to use it, all I'm doing is asking the same way I would if this were plugged in directly to I2C. I'm just printing them. I'm saying, hey, VEML1.lux, just give me the lux value, this brightness value that comes off of that sensor, and VEML2.lux. I'm grabbing them pretty much at the same time. They both come through the multiplexer, and then I'm sleeping for a little moment. And then I'm printing those here in this case using the moo plotter. That's a convenient way to show those. So let's see, let me know if anyone has any questions on this. And I will answer some of these. I haven't used this a lot, so I'm going to guess. Someone asked Evil Dave of Canada, can we chain these together? I believe you can use multiple of the PCA9548s on your one I2C port, or in this case of some chips you have 2 of them. And that is because if you take a look at the bottom here, I'll refocus, you can pick different addresses. You could pick, I think we can have up to 4 of these on a single I2C bus, and then multiply that by 8. So you could have 64 devices going through 4 of these guys here, and you'd just be instantiating them the same way we did, but iterating through them. That's theoretical. I haven't tried that. Lady Ada mentioned that in her video there. If anyone has experience with that and has tried it, let me know. Let's see, other questions about I2C. Oh, I'll jump over to the Discord here so you can see that. DJ Devon3 says, most Adafruit examples show 1 sensor per port, but you can chain STEMMA sensors on each port. Yeah, so you could have, this can get out of hand quickly, for sure. You can have objects chained into those that have non-conflicting addresses, so I could have other I2C devices coming off of the sides here. It's basically a hub, that's right. Hub plugged into a hub, plugged into a hub, oh gosh, yeah. I don't know about that. I'm scared of that. Someone's got to try it. Hey, they're half off right now, right? So if someone wants to try a real weird experiment, get a handful of these and see what you can do. Do your worst. Plug a lot of stuff into it. Just don't forget to pick up a bunch of the little short cables. Those are helpful. Let's see, what else? Check out the YouTube chat here. Hello, everyone. Chaining will change the timing, says Jason Reedy. It'd be 3 transactions rather than 2, plus the decrease in address space on the other side. Yeah, I'm sure there are practical limits to this. Theoretically, it could get up huge, but I'm sure there are practical issues you'll run into. Let's see. I saw another question here that Todd was answering. Let me find that again. How do I jump up to you? There we go. Please state whether this is the PCA9548 or the PCA9548A. And it looks like Todd checked the data sheet and it is the A. Usually, we've got those, if you want to know, I'll usually answer a question like that by heading to the Learn Guide, and then there's a link called Downloads. This will have the data sheet usually, as well as in the schematic, the part name is probably going to be a little more visible. So let's zoom in here. Oh, this actually shows the TCA 9548 in the schematic. That might be the other chip was just easier to grab. So let's check the data sheet. Do we mention it there? Now, sometimes these data sheets will cover a bunch of things, but yeah, this one says PCA9548A. I don't know what the difference is, what the other ones are that are non-A. But yes, if you have questions, you can go to check out this fully featured TI data sheet there. Let's see, other thoughts or questions? Aaron York asks, are there plans for Adafruit to sell a 5 gigahertz based Wi-Fi board? I do not know. I have no idea on that. That'd be a good question for Lamore when she is back. Let's see. And over in the Discord. All right. I think that's going to do it. So let me grab this one back here and we'll wrap this up. So don't forget, you can head to the product page. Go ahead and grab, in fact, there's the product page right there. Oh, and I forgot to show you, there's a very nice close-up of the board there that I threw up there. Head on over there to get it for half price. That is my product pick of the week this week. It is the PCA9548 Multiplexer for I2C. New row. That's going to do it for another episode of JP's Product Pick of the Week for Adafruit Industries. I'm John Park. Thanks so much, and I will see you next time. Bye-bye.